Okay, so welcome back to the second half of the lecture series. And we've got a pretty interesting topic today as well, which is called as reasoning. And that's what we usually do after the assessments, where you ask me reasons. Excuse me, instructor. Why are these marks cut? Excuse me, instructor. Why is this answer wrong? Is this a correct answer which hasn't been given marks? So, in AI, many times we have a lot of questions, and all we want the system, all we want the intelligent system is to give us reasons or to answer all those queries. So now I don't say that, hey, I'm at the source, that's my goal. How do I go from source to goal, the searching problem by this path? I'm not interested right now. Now all that I'm interested is that, hey, if instead of moving up, I take a right, what will happen? So what if instead of a right, I just move ahead for 3 times steps? What will happen? Will I still be able to reach the goal? Will something else happen? Or will I get kidnapped? So we want these reasons, we want these stupid questions to be answered. And that is all what this part of the lecture would be, which is letting the system answer in those kind of queries when I tell it what I know, what I see, what I observe, and everything that I believe is true. Now, if you're still in the first half of the lecture ideology that, hey, eventually the agents need to solve some problem, so eventually my problem is still that I need to act in the real world and do something. Where is this reasoning coming? One way is chatbot, so you ask question and they give you reasons, end level applications. If you still need a more concrete answer, so towards the end, we will combine our reasoning ability of this lecture along with the searching capability of the last lectures and make a powerful system where the searching algorithm asks question, what if this, what if that? The reasoning system answers it up, and I let my agent know what to do and how to act based on this combined knowledge of both the systems. So let's give it a better term. And my better term is my agents will now have a special name called as a knowledge-based agents. And what that means is, if this is, of course, I'm only drawing the agent figure, so it's no longer the environment agent. If this complete thing is what is my agent, this is what will be called as the knowledge base of the agent. So if you're still in C1, this is the complete agent, and it has a memory, which is what is stored in my head. That's called as knowledge. There are two types of interaction that an algorithm or the direct user could do with this agent. One is to tell the agent a fact, a rule, or whatever fancy term you may have it. So these are things that you know are correct. These are correct by the game logic. These are correct by the environment logic. These are correct by the rules of the system. These are correct by laws of nature. Of course, AI doesn't know even stupid things. So each and every little common sense also will have to be told to the agent. And when you tell the agent something, what it does is it writes all these things down. So whatever you tell, it will write it down. And these are the things which I will call as a sentence. So the same English language meanings. Now what I do is that I sometimes also ask questions, and using these knowledge summarized as these sentences, I want my agent to answer that. I want answers to whatever queries that I have raised. If the agent cannot answer that, it can say that, hey, I don't know the answer. Like many people in assessment, so interesting questions. All of you rational agent, I asked questions in the assessments and you say, hey, I cannot answer. Now, it so turns out that, of course, the agent knows all these things that you told them. What also happens is that the agent also knows some things that you did not tell it, and these are called as the derived facts. So something you don't tell the agent, but using the AI, I can derive that up. And because I can derive that up, this is where AI comes into play. Otherwise, I would have said it's nothing but simply a lookup table. So all I want is that my agent should be able to derive whatever you want it to, and that's where AI will come into the picture. Now, there are two types of sentences, and therefore I'll use two types of words. So another term of sentences, axioms, I'll be using it completely informally, interchangeably, sometimes sentence, sometimes axioms. For me, it doesn't make any difference. If you're technically going, then axioms have to be the pure sentences which are told, which are not derived, and sentences anything, a derived fact or a rule which was told to the agent. Both of them absolutely count. I'll give you another quick definition, which is that from a programming sense, we've looked at something which is called as procedural programming. And the procedural programming was, of course, your sentence 1, sentence 2, sentence 3, C++, your all the sequence of statements that happen procedurally. They may be loops, they may be ifs. Now the kind of programming that we'll do in Prolog will be called as declarative, and that's exactly what declarative is. I don't have sets of line 1, line 2, line 3, line 4, line 5, line 6. All I have are two things. I declare things like you declare variables. Int I comma j comma k is exactly same as int k comma I comma j. It has the same effect. So doesn't matter how I declare that up. I'll just declare in a few facts. I'll declare in a few things. And based on that, whenever I ask a question, it should be able to answer using all those facts. So there's no set procedure. Now I say this with a tint, everybody will warn you about it. So of course, even in Prolog or declarative programming, there are some small procedural elements that we intentionally keep for reasons. So let's get into a quick example of what this knowledge base would be. So I give you a few sentences, and something that I very commonly get is that, say the other day, I got a call from a student, anonymous, that, hey man, you took a quiz last week, wonderful. Did you know one guy cheated? I say, no, that's a fact, that's given to me. And that's completely correct. Somebody is taking the onus. So I simply say that yes, there were 3 students who took the quiz, roll number 1, roll number 2, roll number 3, and this fact says either Rule number 1 is not honest, so this means not, and honest R1 is just a symbol. Or rule number 2 is not honest, or rule number 3 is not honest. And unless you want me to repeat it up, so we have started it. There are numerous types of knowledge-based system. We are specifically discussing what is propositional knowledge-based system or propositional logic. So propositional logic means out of all the integers, real numbers, strings that you have been doing in the first part of the lecture, now everything will be just either true or false. So everything will be either based on a true or it will be based on a false. So what is written around over here is, of course, these are called as the propositions or symbols. It could take any one of these values. So they could take a true or they could take false. And my entire syntax is based upon some logical connectors. So these are connectors which relate all these propositional logic in order to make in what I called as a sentence. So hey, you've got an example of a sentence now. Very good. And what I would be doing around over here is that I'll be giving in sentences like this. Now the connectors could be either this, which is called and, or more correctly as a conjunctor or a conjunction. So that's a conjunctor, and what it does is a conjunction. So A and B, and of course the truth table goes that it's only true when both of them are true. So that's what is called as a conjunction, and what A and B are the operators over which are the operands over which this operator is applied, which is the conjunctors over which this conjunction is applied. There's an example of disjunction, of course, which is the or the disjunction. It is true when either of them is true. Of course, you already know that. And this is the not. You also, of course, have in the implies. So A implies B. It's true whenever. So for it, this one, it's easy to say it the other way around. So the only time you can make implies false is if this is true and this is false. Otherwise, it is always true. That's of course which is called as the implication operator, where this has a special name. It's called as a premise, and this has a special name which is called as the conclusion. It's just because it can sometimes be read as if A then B, as A implies B. So similarly, it's also called as an antecedent, and correspondingly B is what is called a consequent. Similarly, we also have A bijection B, so that's a bijection. And of course, this statement is completely equivalent to A implies B and B implies A. So that's standard logic Boolean algebra. I will of course not be repeating any one of these over here. What we will do is to just say, hey, using all that we know, could we do something which is interesting? Could we derive a new facts? Could you tell me something that I did not tell you as a knowledge base? Now, just a small word about the implication, and it could be misunderstood so many times. So if this is false, it doesn't matter what this is, it's always true. So if I tell you a sentence that if today is the year 2025, then it doesn't matter what I say next. Sun rises in the west, sun rises in the east. It's always true. So when the antecedent or the premise is false, it doesn't matter, it'll absolutely be true. In programming, in logic, in English language, you're not used to these sentences being completely valid. If it's 2022, then there is no coronavirus going on. That's an absurd statement that appears to be wrong, but it's absolutely correct because the premise is what is false at the very first place. So it doesn't matter what the consequent is. The statement will absolutely be true. Okay, so coming back to the actual example. So somebody just calls me up and says that, hey, either R1 is not honest because somebody cheated, or R2 is not honest, or hey, maybe it was R3 which wasn't being honest. Something that I know from experience, that if somebody has bad marks, and of course, in the same course, not in any other course. So if R1 is a student of AI and R1 got bad marks, I might just say that the person is honest. So you cheated and you did not score anything. You scored a big fat perfect 0. Bad marks is the intellectual way of saying that. So let's say that R1 should be honest if that happens. And similarly, I could say that if bad marks are 2 and studies AI are 2. So I've got this rule with all students. I'll have to write it down for all of them. These are rules that I have in my life and they hold for all students. So, oops. And studies AI R3 implies honest R3. Let's say that I have another rule, which is what I've done sometimes, which is that if somebody will say that, okay, they might have been cheating, may have been cheating, which is different from this, there has definitely been cheating. So I take a viva, and a good viva from the student R1, and of course, the person needs to be a student of the course. Of course, it also implies that R1 is honest, and I can do that. This rule holds good for all the students. So, if R2 gives a very good viva who's also a student, then implies that R2 is honest. Now, when I write this thing down, I haven't said anything whether R1, R2, R3 gave good viva or not. I did not say whether R1, R2, R3 are students of AI or not. I did not make any such things. All that I'm saying is, using this implication operator, if this holds good, then this implies, it does not mean R3 gave a good viva, it does not mean R1 is a good student. If R1 is a good student, then this implies. Now let's observe some facts. So let's say I observed that R1 actually got a 0. Oh my god, bad student. I also took viva of only one student. I did not have time, and I took it for R3, and guess what? R3 gave a good viva. Now, I'm going intuitively. These facts always hold good, each one of them. So these are rules of my life, and my rules of my life are my own. They are mine, so they are correct. This is what somebody called me up and told. Somebody took the onus, and because that somebody took the onus, it is correct. This is what I observed from my own 2 eyes. And because I observed that up, of course it is correct. What can I deduce? Can I reason something intuitively? We'll do it formally a bit later. Now, if bad marks are one, okay, I also know that these are student in my roll call. So I know studies AI are one, I know studies AI are two, and I know studies AI are three. So, can I give you something from it? The first is that I know that R1 studies AI as well as R1 got good bad marks. So R1 got bad marks and R1 also studies AI. It means R1 has to be honest currently intuitively. So I can somehow derive honest R1. Similarly, I know that studies AI R3 and good Viva R3. So good Viva R3 studies AI R3. Intuitively, I can say that R3 is honest. Now comes the interesting thing. R3 is honest. R1 is honest. Three students, one of them at least cheated. Two are honest, which means definitely R2 is the culprit. Okay, of course, that's not how we operate. That's not how we give you penalties and say you plagiarize. We've got a formal mechanism. This was just a dummy example. So I took three students, I proved two of them are honest, so one of them cheated. That means the third one is what is the person going to be dishonest.